What I'd like to do today is talk to you a little bit about matter. What matter is, how it's combined, how we separate it, and how we classify it. But before we start to do that, I just would like to let you know some of the things that I do here in my laboratory, I don't want you to do at home without permission from your mom or dad or a grown-up around. Okay? I have to get permission, so please, you get permission too. Alright, let's begin. What is matter? Matter is all around us. It's in the air. It's the air that we breathe. It's the floor that we walk on. It's our baseball cards, our video games. It's the rock. It's the dirt. It's grass. It's wood. It is everywhere. Everything on our planet is made out of matter. Now, matter can be broken down into its most simple building blocks. And those building blocks aren't called Legos. They're called elements. Elements are the most simple building blocks that matter can be broken into. They occur naturally in nature. We don't make them. They're just all around us. We discover them. Elements are a lot like the ABCs of your alphabet. ABCs are neatly organized on above your teacher's blackboard in that special way called ABC order, or alphabetical order. Our elements that we find all around in nature are organized as well. Not in ABC order, though. Be right back. I'm back. Now, we took a look at all of our elements and we organized them based on their classification. And then what we did is we put them on a chart or a table based upon the kind of properties that they have. So that chart or table is called the periodic table of elements. And the elements on it are organized based upon the properties they have. For example, gases are put with the gases. Liquids are put with liquids. Metals are put with metals. All organized on what I'm showing you here. Hopefully you can see it, my little iPad, on a periodic table of elements. Now, just like our letters in the alphabet can be combined to form words, our elements can be combined to form not words, but something called compounds. Compounds are combinations of elements to form a completely new type of matter. For example, some ones you might find around your house. If I take the right amount of hydrogen and the right amount of oxygen and I put them together, I can get the compound of water. Water is super important. Everything alive on our planet needs water to survive. People, plants, animals, we all need water. And water is based upon the combinations of hydrogen and oxygen. Here's one that everybody finds all the time. It's sodium plus chlorine making salt. We have it on our French fries, it's on our food, it's even on the salt shaker at your home or your restaurant. This is one that's really popular around Halloween. It's the combination of hydrogen, carbon, and oxygen to make sugar. Sugar's in the sweet treats that we eat. It's in our cupcakes and brownies and all types of things. You might sprinkle a little bit on your Frosty Flakes when you have your breakfast in the morning. That's sugar. And the last compound that I want to talk to you a little bit about that happens all around us, that's easy to find, is called rust. Rust is what you get when you mix iron and oxygen. And you might be looking at this and saying, Mr. Rober, Fe, iron is spelled with an I. There's no F in iron. Well, these symbols that I have here, they're called the shorthand symbols. And every element gets a shorthand symbol either from its Greek or Latin word that it used to be called, or by the name of the scientist who discovered it. A long time ago when iron was found, it was called ferrous. So when you look on your periodic table, you'll see the shorthand symbol for iron is Fe because it used to be called ferrous. Okay, those are my compounds. Now, my compounds can be put together in 3 different types of combinations. I can take compounds and I can mix compounds and elements together to form solutions, or mixtures. And lastly, I can put them together to form something called an alloy. Ooh, sounds tough. Let's talk about mixtures first. Mixtures. A very popular mixture, one that I love to have, is fruit salad. Fruit salad is just a mixture of different kinds of fruits put together in a bowl, stir around with apples and oranges and cherries and grapes to make a wonderful tasting fruit salad. Some of us might like maybe the bananas more, and in our fruit salad we might pick the bananas out. Or we might pick out the apples. Or when we're scooping it, we might try to scoop more of one type of fruit into our little bowl than another. Mixtures are put together unevenly. They're sort of mixed unevenly, and they can be easily separated. For example, I could just go and pick the grapes out that I don't like or that I love and eat them with a fork or my fingers. Or I could just not put them in my bowl. I use the properties of the components of a mixture to separate them. Separate them by its size, its shape, its color, its hardness, its texture. And I use those properties to separate the components of a mixture. Another common mixture that just about everybody runs across is when we cook our pasta noodles. We mix the noodles with the water, we heat that water up and the noodles get cooked. Now we have to separate a mixture of noodle and waters. And in a kitchen, the cook or your mom uses something like this. If you look close, it's called a colander. But a scientist doesn't call this a colander. A scientist calls this a filter. And what this does is this filter allows the small particles of the water to come through its holes, and what it does is it catches the bigger noodles, and we separate them, our pasta from our noodles, using a filter. So, mixtures can be easily separated using tools like filters or just by picking them apart with forks or our fingers. Mixtures aren't evenly mixed. I'd like to talk to you a little bit next about the solution. Now, the difference between a mixture and a solution is very, very simple. A solution is evenly mixed and can't be easily separated. Here's a solution that everybody runs across when you go to the beach. No, it's not sand. It is actually the solution of salt and water put together to make salt water. Now, I've got a little bit of water right here, a little bit of salt in my salt shaker, and I'm going to make some salt water right now. I'm going to shake this into here, make some salt water, put it in there real good. Nice salt water, get some good salt in there. Take a spoon, a couple quick stirs. Next thing you know, I've got salt water. Looks like regular water. All the salt's dissolved in the water. Couldn't even tell just by looking at it. But if I taste it, oh, yuck. Ugh. The first sip is going to be as salty tasting as the last sip because the salt is evenly mixed. Now, how do I separate that salt and water? Can I use a filter? No, my salt particles are now so small they will pass through a filter. Even ones that are with smaller holes than what I have here, just pass right through it. Well, I know that if I set this cup of water on the windowsill, if I set this cup of water on the windowsill, it will eventually evaporate. And you know what it will do? It will leave behind that salt water. It won't leave behind the salt. It'll leave behind the salt from the salt water. But I don't have time in this video to set this cup of water on the windowsill to let it evaporate. So, how can I get the water to go up in the air a little bit faster? What can I do to do that? Let me think about that for a minute. I've got an idea. Let's say I put this salt water in this pan. Put it in this pan. I'm going to put it on my heating element, which in my laboratory is called the stove. Put it on the heating element. And I'm going to bring that water to the temperature of about 212 degrees. Now at that temperature, my water will start to boil, and it'll go up into the air in this room, leaving behind the salty residue on the sides of the bottom of that pan. On the sides of the bottom of that pan. Now, that's going to take a minute or two, so let's just hum the Jeopardy tune. No, really, hum the Jeopardy tune. Ta-da! Wonderful. Turn that off. Bring my pan back over. And as you look inside, all that's left on the bottom is the salt that I shook in just a little while ago. Now, the water actually didn't boil that fast. I did this experiment a little bit ahead of time because I knew it would take a little bit of time to boil all that water off. But if I scrape that salt out, it would be the exact same amount of salt that I put in, all of it being left behind. So, mixtures, easy to separate. I can use tools like a filter, or I can just pick them apart based upon their characteristics or their properties. Solutions, a lot harder to separate. The last combination that I want to talk to you about is something called an alloy. Now, most famous or most popular alloy used today is one called steel. And steel is the combination of chromium, the element chromium, nickel, carbon, and iron. I am able to combine those four elements in a certain quantity under the right circumstances, and I'm able to get this super hard metal called steel. And steel is an alloy. And alloys are combinations of elements with one of them being a metal. The metal in our example, steel, is iron. Iron is much harder than, or steel is much harder than iron. It has allowed us to build bigger bridges, taller buildings. We use it in our cars, things like that, to make safer automobiles. It's used all around us. Another alloy can be easily found in most of the things that your moms or your dads wear in their jewelry. Gold, the element gold, is very soft. So we are able to mix gold with a few other elements to make beautiful jewelry. And it keeps the gold color, and it has real gold in it, but it allows it to be a much easier to work with metal. If I take aluminum, the metal aluminum, and I mix it with some copper, I'm able to create better pots and pans. And those are just some examples of alloys. Now, let's quickly review. Matter is everywhere. It is all around us. Its basic building blocks are called elements, and those elements are organized on something we like to call I don't know if you can see it, the periodic table of elements. Kind of not so good there, but that's what it is. They're organized on that chart based upon their characteristics. The elements can then be combined to form something we like to call compounds, and compounds are all around us. They're salt, compound of salt, the compound of water, the compound of sugar, and the compound of rust. They're all around us. They can form other combinations called solutions, mixtures, and alloys. Mixtures are easily separated. Solutions usually have to go through some sort of process. Thank you for viewing today's video. Remember, if you're going to try any of these experiments at home, please get permission from a grown-up. Good luck on your quiz.